Welcome to solverfy.
We are given a weighted graph, and we are asked to use Prim's algorithm to find a minimum spanning tree for this graph. So, in order to execute Prim's algorithm, first, let T be the graph with the vertices of the given graph and with no edges between the vertices. So, T is just going to be the graph with vertices A, B, C, D, and E. Now, let's select A as the root. So, this is our root. Now there are three edges incident to A in the weighted graph, and we have that AB is the edge that has the smallest weight between these two edges. So we'll add the edge AB. I'll draw these edges in green, which has a weight, recall, of 1. There are two edges incident to A remaining in the graph, and two edges incident to B. Now the smallest weight of these four edges is going to be 2, which belongs to the edge AE. And this edge doesn't cause a circuit, so we can add it to the graph. So now we'll add AE to the graph, which has a length of 2. Now, in the next step, we have that there is one edge incident to the root A remaining in the original graph G, and there are two edges incident to B still, and now there are three edges incident to E. We have that the smallest weight of these edges is all going to be 2, which belongs to the edge DE. And if we add DE, we don't get a circuit, so we can add it to the graph. So we'll add edge DE to the graph of length 2, or weight 2, I should say. And for the next step, we have that there's one edge incident to A remaining in the graph. There's two edges incident to B remaining in the graph. There are three edges incident to E, and there are two edges incident to D. This really should be two edges incident to E, my mistake, and two edges incident to D. We have the smallest weight of all these edges is 1, which belongs to the edge CD. And if we can add this edge, we don't make a circuit, so we can add it to the graph T. So we have CD. And finally, we see that we have a connected graph. So the algorithm terminates, and thus it follows that by Prim's algorithm, this graph is a minimum spanning tree and so we have that the minimum spanning tree consists of these four edges we have edges A, B, A, E, E, D, and DC.